So, guys, today we're going to take a look at this little circular motion activity to kind of introduce the concepts and the topic here of circular motion. So, one of the first things we are going to look at or try here is on a table, slowly roll a ball and push it with a ruler to try and make it travel in a circle. Okay, and then, so the first question is going to be asked then to make the ball travel in a circle, what direction do you have to push the ball? All right, so I'm going to try and do some of this here. I don't know how well it's going to work with the document camera, but let's see. Can I roll this? So if I'm trying to get this to roll in a circle, if I'm just kind of pushing on the outside, it doesn't really kind of do what I want it to do. I need to give it a little bit. What direction do you think that I'm applying the force to try and get it to move in a circle? And then if I just apply a force really quickly, did it move in a circle? If I just let it go, right, I apply a force to it, is it moving in a circle? So to get this thing to move in a circle, what force do you think needs, or what direction of a force do you think needs to be going on here?
Opposite force in this direction.
So as it's like coming to the down part of this curve, as it's coming to like the down part of this curve, what direction do I push left? Do I push right, or try and kind of push inward, do you think, as it's kind of moving? It's not as easy as this looks, or you may think. Let's try and keep it going at a decent enough speed. Because it constantly needs a force on it to make it go into a perfect circle, so we're not going to get a perfect circle here. All right, so to make this thing travel in a circle, what direction do you think you would have to push the ball? If you have a ball at home, you want to try this, you can. To try and move this in a circle for you guys, I do have an extra tennis ball I can lend you real quick to see. So wanted you guys to try and write down what direction you would think what direction you had to try to do to push the ball. Just if you have the ball at home and you did it, awesome. Try and basically write it out what you guys thought, or unfortunately, based off of that terrible demonstration, all right, to try and get this thing to move in a circle, how would you describe you needed to apply a force to this? Why is this difficult to try and get this thing to move in a circle, even if you're just using your finger? But if you're trying to get this thing to do it with a ruler, by pushing it with a ruler, let's see. If you're pushing it from the outside, right? Why is that such a pain to do that? So why is this difficult to do, and what does Newton say about a ball in motion? What direction does it want to keep going? This would tie into Newton's first law, which we had just went over, guys, over the last couple of days, and that was on the test. And also from there, make two observations about how to make the ball move in a circle. how can I make this thing move in a circle? If I'm not applying a force to it, if I'm not applying a force to this, is it going to change its direction? Or does it just kind of keep moving straight? So to get this thing to change direction, there needs to be a force acted on it, but it also needs to be, in a way, a specific direction that we need to use. So if I just drew this little circle here out on my table, how trying to get this thing to move in a circle. This is so not easy, especially at this tight of a circle here.
This is number 1.
Yeah, it's still on the one. Ah. So if I roll it. What direction is the force needing to be applied in order to try and keep this thing in the circle?
Apply force on where you want to put it.
And applied force and where you want to put it. That's not bad. Is there any other idea that you have?
You have to put it behind it rather than forward.
So you're saying I have to push it right? If it's coming this way, I have to push from behind it, or otherwise it.
On this angle, so
So we kind of have an idea that the force seems to me to be on the outside of the object, but on the outside of the object, angled in which direction? Do we want the force angled to the outside? Angled towards the inside. Okay, we're going to keep that in mind. So we have that idea now. So in part B, we got a pie plate here. We have a pie plate and a ball or marble, whatever. Leave it flat on the table. And then roll this here, and you guys are just going to write in, what do you think is keeping the ball in the circle? So I got a little marble here. Just based off of right there, what you saw, what do you think is keeping this guy in the circular path? And then what direction is the force pushing the ball? So guys, the force that's being applied right off the rip is just to kind of get it to start moving, but in order to keep it moving in the circle is what we're looking at for specifically. What do you want? Come on, move faster. All right. So based off, so part or number 3 of activity B here, roll the ball around a cut plate. Let's see if we can get it better from this angle. Let's see what it looks like with the tennis ball. Doesn't really work too good with the tennis ball. So we're gonna go back to the marble. All right, and while I have this going, let's see something here. Can I make? Yep. So it's a slightly different spot. All right, that was actually not bad. So what kind of path does this thing take? What happens to it? And then use Newton's first law to explain that.
I think I'm already waiting for safe. Flat surface, it would be skin definitely.
This is a flat surface.
No, I'm saying the desk might be like a little curved, so it started going like that almost, so it started going towards you.
Are you look on the meat for a second? When you're looking at the meat, what actually happened? It went in a straight line. Didn't continue to curve. Didn't continue to curve. So wait, well, how the hell was it staying in the circle the first time then?
Because it had something to go off of.
Yeah, it had the wall of the plate here. So in like this second piece, all right, what is keeping the ball from rolling, or keeping it rolling in the circle? It'd be like pretty much the walls of the plate. And what direction is that force being applied? What direction was that force being applied, do you think? Oh, that's not where I want to go. What direction do you think would need to be, all right, what direction of the force would need to be there in order to keep this thing moving in a circular path? A downward force from maybe at this spot right here, but essentially, look at how this thing is acting, right? If you're going towards the center, you're going around this. What direction is my finger pointing? At pretty much every spot to keep it like this. You're going to need a force that is directed inward towards the center. You're going to need something that is directed inward towards the center in order for this thing to continue to move in a circle. So when that force was not there, what happened? Well, like Newton's first law said, objects in motion have a tendency to stay in motion unless acted upon by an unbalanced force. So when the wall is gone, come on. There was nothing causing it to change direction, and so it then flew off in a path basically tangent to where it was. So you guys know what tangent is? The tangent part of a circle? So basically a tangent line is a straight line that you can make at any single one point on a circle. So if the object's, can I turn this thing? Nope. All right. So this is a tangent line. If I said, hey, here's my point right here, and it's rotating clockwise, it's pretty much going to shoot out that side. If it was here, it would shoot out this side. If it was over here, it would go out this direction, here, out in this direction, and it would kind of continue moving around, right? So it's assuming, again, it's moving in the clockwise direction. Those would be your tangent lines. So at any single one point, what does the velocity of the object want to be doing? It wants to go straight, because without the force there, geez, come on, finger. Without the force there, that's what happens. Without the force here, what's going to happen? Without it here, it's going to, all right, be the case. So the object's velocity, all right, the velocity of the object wants to go straight. It is unnatural for an object to move in a circle. There needs, as you just saw, something causing that to stay in a circular path. There needs to be a force. And what direction does that force have to be directed? Inward, towards the center, in order to keep this going. And then in activity C, okay, we got to hold a string in your hand and swing it above your head. Do not let go of the string. Hold the string tight. What is keeping the ball going in a circle? And then what direction is the force of the string pulling the ball? Okay. So for this, let's see. I'm upside down now. Let's get rid of all that. And then how do I do this? Do I flip it? All right. So if you have this string and ball, let me just see. I'm swinging it overhead. All right. So what is the question asked again?
What is keeping the ball moving in a circle?
Okay. Well, so what is keeping the ball moving in the circle? Should be a super obvious answer. No trick questions here. The string. And hey, what was one of the 5 contact forces that we talked about? Tension. That is a force. So it's the force of tension between the string and my hand on the ball that is continuing to move it in a circular path. And what was the second part of that?
What direction is the force of the string pushing or pulling the ball?
All right, what direction of the force is the string pushing or pulling the ball? Let me see if it looks better from a spinning this way. I make it a little bit smaller. No, it needs to be a little bit smaller again. What direction do you think the force is acting again?
Outward.
Outward?
Yeah, because there's tension on the string.
Because there's tension on the string. Well, if the force is going outward, right? So if as this thing was coming around, if the force applied here was going outward, what direction would it want to move? Outward. So as you hold on to this thing, the string is holding it inward. The ball naturally wants to do what the marble was doing, fly off in a path straight. So if this thing were, let's see if I just hold it like this, and it wanted to move straight, I'm holding onto it, you can see that it's curving around, right? So that'd be like if you were to do one of these on your finger, I think. Let's see, how's that? Okay. Right, so the ball wants to move in a straight line, but because of this, the force is pulling, if it's pulling outward, it would have a tendency to just go, see it. So what direction actually is the force angled? Inward, again, towards the center. All right, so that, guys, should be hopefully good enough to get through and answer those few observations here. All right.